Oh, hey. Welcome back. Hope everybody enjoyed their daily quiz again. How many of those are we going to have, huh? Man, who knows? Okay. Let's review. Let me pull it up. Let me also pull up the scores first and see how everybody did. I think you guys can see the averages and everything yourselves, but it's nice to know what page everybody is on, as you've probably seen so far. You're not the only one lost. Okay. Although in this case, it looks like you might be the only one lost if you didn't get it, because this one went pretty well. Alright, good. Some of that stuff's coming together a little bit. Good job getting the enums down, too. Alright, so most people gathered that the combination of the two adjectives was an adjective. The second part was a little confusing. I'll go over that briefly. And then the combined text, obviously a pretty confusing statement. You shouldn't make statements like that in your own code because, well, they're confusing. They'll be confusing to yourself in the future, and they'll definitely be confusing to others. But, of course, for a quiz, that's kind of the point. I'll call this package Word. And again, the fastest way to move the stuff that I give you on Canvas or whatever into Eclipse is just to get to the point where you can see all the Java files in your File Explorer and just drag them in. You can say copy and it'll be fine. Now in this case I cheated a little bit because it happens to be that mine has the same name. I totally forgot to link this, didn't I? Yeah. Totally forgot to link it. Good job for me. I hope someone else did it for me. Nice. Thank you for doing that for me since I completely forgot. Now I'm not going to get my 100 subscribers special. Well, that's what you get for not subscribing and hitting the bell, okay? You know, how am I ever going to get monetized if everybody doesn't like, comment, subscribe, hit the bell, and set notifications to maximum, and engage with me nonstop? Huh? How am I ever going to be able to monetize on YouTube? Everyone subscribe to whatever is the channel that that person has with all their subscriptions. You should post your channel so you can pick up another 90 subscribers or so. Okay, so for those who didn't see it last time, quiz breakdown. So most people got the first and the third question. A little bit more missed on the second and the fourth. So for the second and the fourth questions, the trick was that the word has two constructors. And this is described in the comments too, so you didn't necessarily have to go into the code. But you've got the word that's made with a type, which was how the two adjectives are made there, and also fish. It was made as a noun. The two adjectives are made as adjectives. And then Snappleberry was made with a different constructor. It has no second argument. It just has Snappleberry. And that constructor is defined here, the one that just takes text. And you'll notice that that one, it says in the comments, creates a new word with type other. And you see that down here as well. So if you don't specify, it just gives you a type other, which is not an uncommon way for things to be done. I remembered to put my bars on today. Let's see. That would be the second question here, where it asks you, what is the combined type? So when you combine the combined color with definitely a word, which has a type of other, because it hasn't been defined here. And then the combined type, which almost everybody got from question 1, is an adjective. What do you get? Well, let's see. So when you combine two words into a new word, if they have the same type, then the new combined word is also that type. Otherwise, the type is other. So since they don't have the same type, then the other type applies. So it must be other. And you can see that in the code too. If the first type is equal to the second type, then the new word gets the first type as its return. Otherwise, it uses this other constructor that always gives it other, so it doesn't specify the type. Okay, and the last one that some people got wrong was this combination. So let's just write out how this works in the comments. So first, in combines, I'm going to get this. Definitely a word with whatever the product of fish plus whatever the product of red plus blue is. And that's basically how it works there. That's how it looks mathematically anyway. Is that the right answer? Is it going to be definitely a word which is snappleberry plus fish plus red plus blue? Well, okay, word.combine red plus blue gives us red blue. And then word.combine fish, and then what we got out of that gives us fish red blue. And then word.combine definitely a word, and what we got out of that gives us snappleberry fish red blue. Let's see if that's what we get here. We get snappleberry fish red blue with type other. So there you go. So it's just an order of operations thing. Something you should get familiar with. It's not different particularly than like multiplying or adding with parentheses. You can treat these method invocations like parentheses usually, and you should get familiar with nested statements like this because they do save space, and some programmers like to use them, and you'll have to read their code even if you're not the kind of person who likes to use them. So something to be acquainted with. Okay, so when we last left off with the other stuff, we were looking at ramen, and we were making ramen out of noodles. I think we'll all recall. Noodles, to review, have three properties. Are they delicious? Is delicious? Is eaten? Calories. And then they have a method called eat. Eat. We were debating what it should do when we left off last time. But then there's also get is eaten, get is delicious, get calories. So just getters for all those things. You can't change value of noodle after you create it. And noodle doesn't have a constructor, but I showed you what happens if you don't specify a constructor. You basically get a little blank one like this. So that's the default that appears whenever you don't specify one. Usually that's in the background and you don't see it, but there's no such thing as an object without a constructor. They all just get this little blank default one. So for the homework, you had to create your own toString method. That's another thing that all objects get without having it. They all inherit that from object. We'll talk about inheritance quite a bit later, but that's something that you should think about now, is that all objects automatically have a few of those methods. Let me just cheat and go to the driver for a second. So noodle n equals new noodle. And let's look at the methods that n has. So it's got eat, right? And it's got like get calories and get delicious and get is eaten. But also has a few others. It has equals. It has hash code, notify all, wait. It has toString. So there's some that automatically come with every object. You can just think of them that way. And you can override these and do your own thing with them. So a lot of objects will use .equals in order to compare two different objects. So string obviously uses this to compare the contents. So if you wanted to compare two noodles, you would compare if they're the same deliciousness or the same calories or something. So you would write your own version of .equals to, we say, override this one. The one that you have to do for the homework is toString. Let's see what happens if we just use the toString that you inherit for free. Well, it helps if I print it, doesn't it? All right, so we get this weird statement here with like an @ sign and stuff. So anytime you see this, you're printing an object reference. And that's what the default toString always does, is it prints out the object reference. So every time you make an object, Java assigns it this ID, basically, for the program to be able to keep track of it. So every instance of an object gets this ID. And when you print that instance, that ID out, you get this. You get the package name, the class name, this @ symbol, and then that object's ID. So if I made some other noodles, let me actually just bum off of the ramen bowl that I have here. So oh, can I access the noodles? Did I make that public? No, I didn't, darn. Okay, so I'll just make a couple new noodles and we'll see. Bad variable names, but just for demonstration. Let's see what their IDs are. So we'll see that they're all unique, and they're all pretty random. They don't really have any rhyme or reason to them. They are basically hex, which doesn't particularly matter here, but remember hex is base 16, so values can be between 0 and F. So we've got 1, 2, 3, 4, 5, 6, 7, 8 hex digits here, so we can do the math there and see how big that is, how many different possible objects we can support. The answer is enough for this not to be a problem 99.99% of the time. So just something to think about whenever you see that class name, ID thing, package name, that's you're printing the object's reference, you're printing the object's unique ID. You will generally not use this for anything too, but it is helpful to use for debugging. If you want to see if a particular object has made it somewhere, you can use its toString method to print this out. Now you know what that object's reference is, and then you can track it throughout the rest of your program, see if it's appearing in the places that you want it to appear in. Okay. Oh, and another thing. If I run it again, take a look at that first number. It starts with 7D, right? If I run it again, 7D again. And if I run it again, 7D again. So these IDs are at least relatively persistent between runs. So you can identify the ID of an object the first time that you run the program, and then go and paste some statements in later to debug it. So it's still persistent, even after a change. Okay, but that's not what you're writing. Obviously, you're overwriting the toString method, and you are making it print out a common English version of the color that you're making. So let's do the same thing for noodle. Let's write our toString method for noodle. So it has to be exactly the same arguments, exactly the same name. And if we do that, let me just put a return null here. The way that we confirm that it is successfully overwriting that toString method is we'll see this tiny little arrow appear on the left of the method name in Java, and it'll say, if we hover over it, overrides java.lang.object.toString. So that's how we know that we've overridden a method that we've inherited. So what do I want to return for a noodle? Let's see. A noodle with calories, yeah, that's good enough. Let's print that out. And then back to the driver. Shouldn't have erased that stuff. Bring that back. Let's print out a couple of noodle fun facts. There we go, that's a noodle with 5 calories. And restoring back all of these, now all of the toString methods print that out. So now a little bit less utility for debugging, right? So be careful about overwriting the toString method if you feel like you might need it one day. But you'll notice that most of the built-in Java objects have overridden toString and have some kind of sensible output instead. Okay, so back to the eat thing. You're talking about where to implement certain functionality in eat versus in bite on the bowl. So when you take a bite of the bowl, you eat a certain quantity of noodles. And then we were trying to determine whether these checks, the if not is eaten should occur on the noodle or on the bowl? And the answer is, it depends, of course. It's up to you. I think it's most practical probably to keep these on the noodle, so the noodle checks if it has been eaten and does all the setup accordingly. Do we need to return the calories here? We have access to the calories through the get calories method as well, so you could just get them after you eat them. The advantage here is that it doesn't just tell you the noodle's calories, it also gives you a hint about whether or not this operation was successful. If it returns 0, then that eating operation was unsuccessful. And it also allows us to ultimately make one-line wonders like this, which are very convenient. So rather than having to say something like calories equals n dot get calories, and then we would have to say n dot eat, and then we would have to say, or I guess we could just say calories plus equals n dot get calories or something like that. If n dot eat was successful, so we would have to say if n dot eat greater than 0, and then we would have to say plus calories, something like that would probably be what we'd end up with. I mean, that's much longer and harder to understand. This, on the other hand, is really straightforward. So calories plus equals, and then you attempt to eat the noodle, and it tells you if the noodle is uneaten, sets it to eaten, returns how many calories you ate, otherwise does nothing and returns 0. That means that if the noodle is already eaten, it does nothing, and we can plus equals our calories to that without fear. The other thing that I want you to get used to from statements like this is that you can call a function, just like we had with that daisy chain of combines in the quiz. You can call a function and do something else in the same line. So in this case, I'm incrementing calories. At the same time, I'm calling that eat function in the same line, at least, anyway. Any questions about the picking of a random index? Because this is something that we're going to do a lot. So I picked a random index out of the noodles array. Remember, every bowl has an array of noodles. You set the size of it when you specify the bowl, or there's another constructor to use the default amount, or there's yet another constructor to make a bowl out of the noodles you provide. And then we have refilling it with fresh noodles for the previous two options. So any questions about picking a random index? That's something that we're going to do a lot. So just math.random times the length of the array, cast that to an integer, and you've successfully picked a random index. Okay. So that was with the noodles example. Let's go back to it. So in the driver, I was taking a few bites, and then I was printing out the calories eaten total every time. And we'll see that I was picking a random index out of the noodles array every time and trying to eat it. So if I picked one that was already eaten, it would do nothing, right? If I picked one that was already eaten. Let's see if we can write a method to return how many noodles are left uneaten in the bowl. So we're going to write a method that returns how many are yet uneaten in the bowl. We'll call it get uneaten count or something. So same thing, we're going to loop through the noodles array. I equals 0, I is less than, and then the length of it. I'll have a count here. And then how do we tell if a noodle is uneaten? What should be the check that we perform here? If something. How do we figure out if a noodle is uneaten? Something happens in that if statement. We'll increment count, and then at the end, of course, we'll return it. What do we do inside that if statement? How do we check for the uneatenness of a noodle. Okay. No answers. We'll just move on. We'll do it. All right. Well, I give you a few more seconds in either chat. How do you check if some noodle in the array is uneaten? How do you check? We do have an isEaten function. We have a getIsEaten here. Although if we didn't, that would be the first step, right? We would have to make one, something to return whether or not our noodle is eaten in the first place. So we're just going to use that method. So it's definitely going to be getIsEaten. What about the rest of it there? What do we put on the side there? Is it noodle? Is it noodles? That doesn't work, right? It's missing something. Yeah, it's missing that of I thing. This is a common mistake that people get stuck on for a while. They try to call methods from an object on an array of those objects. So remember, noodles is an array of noodles. It's not just one. If you want access to one of those, you're always going to have to use an index. So just like I did over here where I pulled one noodle out of the array. So same thing here. You're always going to have to pull one object out of it with an index in order to use any of those methods. So notice I did it in one line here too. I could have done the same thing I did up here where I had noodle n equals noodles of I, like that, and then I could have called n.getIsEaten instead. The reason I didn't do that is because I don't actually need anything from the noodle except that one method, so having it be a one-off like that is perfectly fine. Okay, so let's add that to our function here. Let's say that after we perform all of these eats, we're going to print out the number of uneaten noodles. So you got 45 left after a start of 150 on this run, and then 39 a different run, and then 47 a different run. Remember, because byte picks a random quantity, so you might end up with more or less. Okay, so that's set. Now let's reproduce both of these with grape. Okay, I'm going to basically copy everything that I've made for noodle and update it to grape. Looks like I have pretty much everything already there. I'm just missing that eat method, and I'll just leave toString off because it doesn't matter in this case. Obviously got to be careful when you copy to make sure that your comments are still accurate. Of course, it's not a noodle now, it's a grape, so I had to change those words. We'll see later how to accomplish this with less copying. Okay, so if ramen is a dish that is made out of noodles, I don't think there are any dishes made of grapes, so we'll just call it grape bowl. Grape bowl. My favorite daily snack. I'm going to copy all of this into it, and we're going to do it with grapes instead. But I'm going to make one significant change before I do that. I'm going to go to grape, and I'm going to get rid of the is eaten field, and I'm going to get rid of all of the is eaten functionality. And instead of having that flag, when a grape's eaten, I'm going to set its value to null in whatever array that it's inside of. So I'm going to do that instead. And we'll see how we can pull that off instead. So already I have errors. I have this problem here where the grape can't check if it itself is null. We can't do, if I'm not null. That doesn't make sense. We have no, this stud equals null thing. That doesn't work. We can't do that. Because if you were able to say this stud equals, then you wouldn't be null. And if you were null, then this stud equals would fail because it'd be a null exception. So that doesn't work. In that case, this whole method is going to have to change. We're going to have to return the number of calories and then figure out how it is that we're going to manage grapes that are already consumed. Okay, so that was the first change we had to make. Now, a bunch of things here that need to be renamed, so every instance of grape bowl has to be replaced with ramen. I could go on and do this one thing at a time, right? That would be annoying. Or I could go to right-click on the variable name that I want renamed everywhere, and then go to refactor, and then go to rename. And if I type a new name here, you'll see that it updates it everywhere. So I went to right-click, refactor, and rename, and now it's updated everywhere. Here I'm going to do the same thing. Instead of default noodle amount, it's obviously default grape amount. Instead of noodles for bite, right-click, refactor, rename. You can also learn the keyboard hotkey. It's Alt-Shift-T. That one's a little too much for me. Okay. And then you can also update all the different occurrences of some text. This one's a little bit harder to do. I don't quite remember what the command is, but you can also just use the standard find and replace, which is Control F, or find it in edit. So edit, find, replace, or just hit Control F, and you can change every occurrence of ramen to grape. So let's try that out. Find ramen, replace with grape. Okay, great. Find noodle, replace with grape. Looks pretty good, except I accidentally broke some of my other references here. First of all, there is no object called grape with a lowercase g, so that had to change to uppercase G grape. These broke too when I set it to lowercase g. Some of the references sound kind of funny now. I've got bowl of grape, but whatever. Normally, you're not going to copy and paste swaths of code like this. There's going to be a better way to do it, which we'll obviously look at later. But when you do have to copy swaths of code, it's not like it's never going to happen. Make sure you take advantage of the refactor tool and the find and replace tool, rather than having to hunt down and peck out every possible occurrence. This is also a good reason why you need to make sure that you type at least semi-accurately, because if you make a typo that doesn't get replaced, well, that's a little bit annoying. And yes, at a certain point you get to the part where it's, better to just do it manually. Okay, so how do we handle this with the check for whether a grape is eaten or not to be that it becomes null rather than, setting its is eaten value? So first, what changes about bite is that after we consume the grape, we have to set it to null. So can we do this? Remember, we picked a random grape out of the array. So I inherited from picking a random noodle. So we picked a random grape out of the array. We added its calories to the total. Can we do this to set it to null? So I'll take a poll. Will this n equals null thing work? I think the poll bot doesn't like the use of null very much. That's funny. Okay, so while we're thinking about that, how do we change this? So rather than is grapes of I is uneaten, well, that's simple, right? That's just going to be whether grapes of I is not equal to null. We saw that last time a few times as well, the null check we have to get familiar with. So now our array, rather than having non-existent eaten noodles in it, is going to have spots, references for grapes that no longer exist, so nulls. Okay, so to driver, I'll copy this and make another one for grapes. Let me also print out something here so we know where it ends. Just change those values there. Now, how do I do a quick refactor on all of these without affecting these? Okay, so there's some trick to doing this. One way is to take the part that you were pasting and paste it elsewhere first, do the find and replace there, and then go back. The other way is to copy all of this to preserve it, basically. So I'm just going to copy that to preserve it. And then do the refactoring here. So I can do this one, refactor, rename. That's going to be grape bowl. And then I'll do this one to refactor, rename, calories eaten, total, grape. Okay, so I fixed that, and now I still have the old thing on my clipboard, so I'll just paste it back in there. So that's one way to do it. The other way would have been to paste all this stuff to some other empty class, do all the renaming there, and then paste it back. That works too. Again, you shouldn't be pasting large swaths of code regularly, but it is an inevitability in any large project. Okay, so that should be all set. Let's see if it worked. Let's see if our setting it to null worked. So there are 150 uneaten grapes at the end, and every time we seem to eat the same quantity. Maybe it was just a fluke. No, it seems like there's always 150 uneaten grapes. So what that's telling me is that all of them are not null, because if they were null, then they wouldn't have been eaten when they got picked here. This n.eat would fail. So this doesn't work because this sets the reference n to null. And we don't care about the reference n. What we're trying to set to null is the spot in the grapes array that we just pulled the grape out of. That's what we actually care about. So we have this grapes array. That's where we want to set the grape equal to null. So how do I do that? How do I convert this so that I can set the index that we've picked to null? Well, I have to do some retyping, don't I? Because I have this random index chosen here. And then I just throw it away. I use n from that point forward. So now I need to preserve the random index to use it anyway, somewhere else. Let's call it you can call it random pick, something like that. Try to avoid where it's like index. That's just too vague. It's a pick. Go with pick. Alright, so I'll do that instead. And then rather than setting n to null, I'm setting, well, grapes of pick to null. So that clears out some spots in the array as we eat these grapes. So anytime a grape gets eaten, it gets set to null. Let's run this again and see what the problems are this time. So I get a null pointer exception, and if I follow it, I see the topmost thing in my program is this line 58. which I mentioned would be a problem just a moment ago. So what's the problem here, and how do I fix it? So in either chat, what do I need to add in order to fix this null pointer exception that I've created? What do I need to add to fix this null pointer exception I created on line 58? So it's said to do grapes of pick.eat instead. Yeah, we can actually get rid of n altogether. We don't actually need n anymore. So let's see what happens when I do that. I still get it. I still get it. So the problem is that we have a bunch of grapes in an array like this. Let's say that each grape is called G or something. Okay. And then in order to eat them, what we're doing is we're just getting rid of them. And when we get rid of them in the array, we just set their spot to null. What happens when you try to do null.eat? Well, that doesn't work. You can't call an object's methods from null. You have to have an instance of it. You have to have instantiated it. So since we basically uninstantiated those spots in the array and we tried to call on those nulls, that doesn't work. So we need to add a null check here before we try to eat. And this is going to be something that you do a lot too. Anytime you try to call an object's methods, if there's any chance that that object is null before the method is called, you're going to need to perform a null check. Oops. So, if it's not equal to null, then we're going to eat it. Let's see if that works now. There we go. Then now we can eat grapes too. So now we have 108 uneaten, 105 uneaten, etc. It works pretty much the same way as the ramen one does. Although I don't know why we have so many more. Oh, because we only ate the grapes once, I think, right? Why do we have so many more uneaten grapes than uneaten ramens? Well, that's just weird. What did I do differently? Huh. Go figure. Is that just a fluke? I think that is just a fluke. We'll chalk it up to that. I don't know. I'm not sure why I have so many more uneaten grapes than I have uneaten noodles. Okay, so that's going to be it for this example, I think. Let's see, do I have anything else I want to go over on this one? No, not really. All right, that's it. I guess since we're doing something similar on the homework, let's make one more method. Let's do it on grape, for example. Let's make a method that combines two bowls of grapes together and returns one larger bowl that contains the combined total of all of their grapes. So let's make a method that takes two bowls of grapes, combines them together, and makes you a new one with all of the grapes. This is something that I'll show you in a second we can't really do quite as easily on the ramen variant, because the only mechanism that we have for removing something from the array in the ramen variant is to set it to is eaten, so to eat it. We have another mechanism to remove things from the grape mechanism. We can set the spots in the grapes array to null instead, which allows us to empty out a bowl without actually eating the grapes. They don't have a state here. They can just be null or not. Okay, so let's think about what that method's going to look like. So first, should it be static or not? And it's going to return a grape bowl. I'll just put a filler in there for now. Okay, so static or not? Combine is static or not? So we're going to take two bowls and combine them together. So I guess the answer is it depends. But let's look at the arguments both ways. So let's say that the implementation of combine is that you're combining one bowl with another. That's kind of how the blend looks on your homework, right? So you're taking one bowl and it's being combined with another one, and then you're going to return a third one as an output. That's one way to think about it. In that case, it shouldn't be static because you need the first bowl, and then the second bowl is obviously going to be the other one, and the output is that third one. But the other way to look at it is you have two bowls, first and second, you take them both as arguments. In that case, it should be static because you should be able to access this without having a grape bowl already as a reference. So we should be able to take two bowls together and then do something like this. So in driver we should be able to say, just use the name of the class. Let's say that we have a second bowl here. Another grape bowl. So let's say that we have the name of the class and we want to do combine, and then we would combine a grape bowl with another grape bowl, right? And that's going to create us a third one that way. In that case, it can be static because then we don't necessarily need to already have one. But it also could not be static. Up to you. Static is better in this case because then you don't need a reference to it in order to call that combine method. So let me do the static variant because I find that one's a little bit more confusing. Nobody really answered their preference, so we'll just do the static one. Just only have one answer to the survey. Okay, so combining these two together, what does that mean? What does it mean if two bowls are combined? Well, I guess it means that the array containing all of the grapes in the destination gets all the grapes of both of these bowls, and then both of these bowls get emptied out, right? So empties out the two bowls supplied as arguments and puts all their grapes into a new bowl. Empties out the two bowls supplied as arguments and puts all their grapes into a new grape bowl. Okay. How do we accomplish that? Well, we're going to probably use this fancy constructor here, the one that takes an array of grapes. And here's how we're going to do it. So first we're going to figure out how many grapes are in both bowls. And how do we do that? How do we figure out how many grapes are in both bowls? Any ideas? What's a quick way to figure out how many grapes are in both bowls? So here's the process. Figure out how many grapes are in both bowls. Make an array of grapes that big. Copy all the grapes into it. Make a new grape bowl using that array. And then last but not least, update the first and second bowls arrays to all null. So step one, figure out how many grapes are in both bowls. This is a much harder example than the one on your homework. The one on your homework is just the combination of two objects, and the first and the second are not to be destroyed in that example. You preserve them. In this case, we're symbolically transferring all the grapes out of the first bowl into the second. We do have a variable that measures the size of the bowl. It's basically just the length of the grapes array. That's the size of the bowl. So when you specify a bowl, you specify the size of the grapes array. However, many of those spots are null, and we don't really want to copy those over. I mean, we can. That would be fine, but it's kind of unnecessary. So what if we just wanted to copy the non-null grapes? So we want to see how many are left in both bowls. So we have this get uneaten count. The get uneaten count is the number that's left. So like the answer in Discord said, we can figure out how many grapes are left, int grapes left, by combining the uneaten grape count from the first and second bowls. From the first and second bowls there. And we can even test this out before we move further and see if this is accurate. So let's say grape bowl combined. Okay, and then I'll call the combined dot get uneaten count. You know what? I will just do a printout here to make it easier. So forgot to save. If you made a method in another class and then you invoked it, let's say in driver, but you haven't saved the class where you made the method yet, you'll have an error until you saved. So if you know for sure that you accidentally made it, just go back and save. And sometimes when you run into errors, the best thing to do is just to quickly go and save everything. So you could go to save all, or hit Control-Shift-S to save everything and see if the error goes away. So that can be your first step when you get an error that says that a method doesn't exist when you're confident that it does. Yeah, let's print this out before we go any further with these steps and see what it tells us. So if there were 109 uneaten grapes in the first bowl, and then I made a new one with 150, and I combined them together, then 259? Yeah, that sounds right. Okay, so that looks correct. Let's move on. All right, we're going to make an array of grapes that is that big. So I think I called it grape. I called it grapes left. So that's that part done. Now I need to copy all of the grapes from the first and the second bowl into that new one. How do I do that? How do I copy all the ones? Just the uneaten ones, obviously. I don't want to copy the nulls because I don't have room for it anymore. I only have room for the not null grapes in there. How do I copy all of them from the first bowl into the new one? Someone said for loop, which is a good answer. So let's go with I equals 0. I is less than first dot. Now what? So I don't have the access. I don't have access to the grapes array because it's private, which means I also don't have access to its length. So what do I need to do now? Since I don't have access to the grapes array and I don't have access to its length. Well, I could do a couple things. I could set it to public if I wanted access to it everywhere, but then you could just add and remove grapes from this bowl whenever you wanted, which, if that's something you want to do, fine. Or I could make a getter for it, right? I could add a getGrapesArray method or getGrapes method. So I could add a public grape getGrapes method that returns the grapes array. So I could do either of those things. I'm going to keep it private and work with that getGrapes method and see when we run into our next roadblock. So it would be first dot getGrapes dot length, and then I'll copy the values into my new array. So I called it grapes there. So let's say grapes of I, and then what do I do here? How do I copy them into the new guy? I mean, what do I do? Is it just this? Is it just that, or is there a problem with that? So this .getGrapes we can't even do here because this is static, so we can't access any of those not static fields at the top. one of the reasons I decided to go with the static option. It's a little harder. And anyway, we don't want to, because we don't want to get this grape bowl as grapes. We want to get the first bowls and the second bowls. Those are the two that we're interested in. This is a static method that doesn't refer to any particular bowl. The references you get are to first and to second. So this kind of works, but what's the problem with it? Well, let's say that first.getGrapes looks like this. It's got some grapes, and then some nulls, and then some grapes, and then some nulls. So what do you end up with when you copy this index for index? Well, you're going to end up with the same thing in grapes of I. But remember, we only wanted to copy the not null ones. We only wanted to copy the not null ones. So how do we copy just the not null grapes in the grapes array of first? This statement might look awkward for some people, this first.getGrapes of I. So remember that this returns an array. The getGrapes method here returns an array. So we could maybe make this a slightly less awkward syntax. We could say grape first grapes array, and then we could do this. That might look somewhat less awkward for many of you, right? We would use that instead. And it would omit us having to keep typing that get grapes thing, which does look a little bit awkward. So this is a fine approach if that's how you want to do it. But I do want you to get familiar with this syntax too. It's possible to get an array returned to you from a method and then immediately use its index like that. So a null check. All right, so if first.getGrapes of I is not equal to null, then we do this. Okay, that still has the same problem though, right? Because what happens when we find a null spot? Again, let's say that this is the first grape array here. So when we find a null spot, we just don't copy it. And if we don't copy it, what do we end up with in our new grapes array? Well, we end up with the default value, which is null still. So if the new array will end up looking exactly the same. It'll be a G, and then this one will skip over. We won't copy it, which means it ends up as its default value, which is null. And then we'll copy that grape over, and copy that grape over, and then this one gets skipped over, and it's null, so nothing happens there. But what I want is all the grapes in a row with no nulls between them. What I want. So I want to skip over the nulls but still copy all of them. So how do I get closer to that third column? How do I get closer to what I want? This is the first step, so that is correct. But I need something else too. We did something a little bit similar to this when we tracked what the next available spot to insert a doodad was in a doodad processor. We had an array of doodads. They were all null at the start. And then we needed an extra variable to keep track of what was the next available index that we have to insert into. And we need to do the same thing here. We need a variable that tracks the next available index in the grapes array. So we need something like next index or next grape or next spot, something like that. So let's go with, let's say next index. And it starts with 0. Rather than inserting our things at I, we insert them at next index. And then every time we make an insertion like this, we increment next index by 1. So we're always tracking the next available index in the grapes array that way. And if you review this, you'll see that now, whenever we encounter a null spot, we do nothing, but our index doesn't increment either. So this doesn't evaluate, so we do nothing. The index doesn't increment either. And the next time we find a non-null grape, we add it to the next available spot. Okay, we can get rid of this too, since we didn't end up using it. Well, let's use it for the second one, so I can show you the difference between the two syntaxes. That copies all of them out of the first. Now we have to do the same thing to copy them out of the second. So I'll call the second grapes array instead. So it'll be second.getGrapes, and then let's do the same thing. So it's going to be for the second, and second. And now we've successfully added all the grapes from the first and the second array into the new one, so we finished that step. Let's actually try to do the last step next. Let's try to update the first and second bowls arrays to all null. So I want to update both first and second's grape arrays to be all null. How can I do that? Could I do, let's say, second grapes of I equals null? Could I do that? Second grapes array of I equals null. Can I do that? Will that empty them out? Would that empty them out? And likewise, I'll do the same thing on the first.getGrapes thing. I'll do first.getGrapes of I equals null. So attempt to empty the first bowl, and well, just say empty the bowl. Use it for both. Is that going to work? Let's see. So I haven't finished this yet. I'm still returning null and everything. But let's see, after that statement executes, I'm going to call this line again on my original grape bowl. So it should have, 100-something grapes or whatever in it the first time, and then the second time it should have 0 if I successfully emptied them all out. Indeed, I do have 0 the second time. But think about it. How did that work, right? So I didn't use a setter. I got access to the grapes array through this getter method. Okay, and then I was able to change its indexes to null. So is this variable really private? I'm able to change its fields by using the getter. You can think of this as a quirk or a disadvantage or, I don't know, just some weirdness in Java. You don't need a setter to change elements in the array. As long as you have a reference to the array, so as long as you're able to get it, you can start changing different indexes there without a setter. The only thing you would need a setter for would be if you wanted to declare a new array. So if you wanted to change the size, or just declare a whole new array for some reason, then you would need a setter. But do you? What if we did this? What if we did first.getGrapes equals new grape 10? Can we do that? No, that doesn't parse, sorry. Let's try doing it on the version that we already did here, the second one. Let's say second grapes array is new grape 10. Interesting, huh? Okay, so that seems like it shouldn't work. Let's go ahead and just randomly fill one of those indexes with a grape. So second grapes array of 0 is a new grape. So if this worked, then we should have an array with 1 grape in it. So our way to test if it works is going to be to print out the number of uneaten grapes in that second one, which is the second bowl that I specified here as an argument. So if that's a 1, then it worked. It's 149. 149. Huh. Oh, let's go back. Hold on a second. Let's get rid of these 2 lines. What's going on here? Run it again. It's 0 now. bring that back. It's 149. Don't mess with arrays in the getter method, I guess is the moral of the story. It's just hard to follow, I guess, is the main problem that I have with it. Or at least it's definitely hard for me to follow. Yeah, we only have a little bit left, so let's move on. I will leave these mysteries to next time for you to think about. How come this changes it to 149 when you include those two lines? But then when you add them, or when you omit them, it works and gives you 0 again. So our attempt to empty the bowl worked. We were able to set all the spots to null here, so we've done the last part here. And now we just need to make a new grape bowl using the array of grapes that we have, and we should know how to do that. That's pretty easy. It's new grape bowl, and then luckily we already have a constructor that takes an array as an argument, so we'll be able to just supply that directly. Cool. Okay, so now that we've made that combined bowl, I'm going to update these print statements a little. Uneaten in first bowl, uneaten in second bowl, and then we'll do one more, and we'll say uneaten in the combined bowl. In the new combined bowl, would be this one, and that should be the total number of uneaten ones that they had before, which is now 259. Let me make this printing a little bit more clear. Let's say uneaten in first bowl, uneaten in second bowl, and then I'll do a print here. Attempting to combine bowls. And so finally we have 107 grapes combining with 150. The first two are emptied out, and then the new one now has 257 grapes in it. Okay, so that's how you would do a strange little array combination like this. Now normally, again, you're not going to want to empty out those first two. That would be weird. Normally they would probably still keep whatever object they have in them, but since we're abstracting real-world objects, a grape can't be in two places at once, so we empty them out. Let's say, speaking of having grapes in two places at once, right? Let's say that we want to print out, after the first bowl here, I'm going to print out the first grape bowl dot get grapes of 0. Let's print out that guy. And it's possible that this crashes. Why? Because it's possible that the index 0 is null. Forgot my toString method, which is my goal here. So it's possible that it crashes because it's null. So if I ran this many times, I'd probably eventually get an error when that, yep, there we go, when that grape ends up being nullified. What if I just tried to print it out like that? What would I get? I got unlucky here. I got null the very first try. Let's try again. So I see I get this thing there. So it's going to try to call the toString method for me. But the difference is that if it does end up being null, this isn't going to crash for reasons that don't particularly matter here. Just this is the safer way to print out just object references, if that's what you're interested in. Because see, I have null here, and it did not crash. Now let me see also, after I've combined the bowls together, what is the object reference of the first grape in the combined array? Well, for a non-null execution, we see it's actually the same grape. Remember, we just copied him into the new array and then made a grape bowl with that array. So it is the same one. We haven't made a new grape. We've just passed its reference around from one place to another. So it used to be in grape bowl of 0, and now it's in combined of 0. So objects can move around without having to be reinstantiated. It's still the same grape. We never said new grape anywhere. It just moved from one array to another and was preserved. Okay, that's it for today. Next time, we'll look at some Java classes and how they do it. Maybe run through another couple real-world-ish examples. Remember, the homework's been extended to Tuesday. If you have any problems with it, see me during office hours or send me a message. And I'll see you guys next time when there may or may not be another quiz. Who knows? Alright, see ya.